All right, so 6.2. Friday we multiplied. Today we're going to factor, we're going to graph, and we're going to find the zeros of a function. So as you're looking at your notes, we'll get this up on the screen in a second. The first one has x cubed plus 7x squared plus 10x. And so we got to look at that, and we have to say to ourselves, okay, what are we going to do here? How are we going to deal with this? Can you think of a GCF that goes into that first piece? We all agree it's x? Okay, so let's take an x out. And what's left inside? X squared, 7x, and 10. We agree? Think back with me. How do you factor x squared plus 7x plus 10? First of all, what are the signs? Do we agree they're plus and plus? Okay. X and x. I'm assuming Mrs. Napier and I were doing the same thing. What multiplies to 10 that adds to 7? 2 and 5. And there we go. It's factored. Now, could you have said x plus 5 then x plus 2? Could the x be all the way at the back? Yeah. Any one of those is fine. It doesn't really matter. The order doesn't matter. It's fine. So let's slide over to the next one. Raise your hand if you know the GCF here. Curious how many can pick it out quickly. All right, Jessica? 3x. 3x. Can you take it out for me, please, Jessica?
Negative x.
Well, first x squared, right?
Right.
Then, okay, then you're ahead of me. Then x, okay.
Minus 12.
Minus 12, okay. So I bring down my 3x. Jessica, what are my signs? Plus or minus, because of that minus there, that leads to the plus and minus. All right, and then what are my factors of 12? Let's see, 1 and 12, 2 and 6, 3 and 4. Which one combined to negative 1x? 3 and 4? Okay, which is positive, which is negative? 3 is positive, okay. So positive 3, negative 4. There we go. Factoring. Where are you? I really know it well, so, really struggling. Okay, so most of us are in decent shape. All right. Okay, let's keep going. That's just a little review. Now we're going to talk about some new ideas. When I used to live in Kenya, we went on a hike and we climbed Mount Kenya. And for those of you who know, my son Kent, my wife was pregnant with Kent at the time, this is a number of years ago, and we would get to a hill and our guide would be all excited, and so we'd be like, okay, is that the top? And he's like, well, kind of. And so we'd climb up to this ridge, and then it would go down to another valley, and then it would go up to another ridge. And so it was kind of like a relative top, but then we'd go down to a bottom, and then we'd climb up to another one, and we'd be like, okay, are we almost there yet? Because it's just over the next hill. And we get to the top of that hill, and then we go down again, and then up to another one. And every single time we did it, it was always, oh, just 20 minutes more. And he was just trying to be encouraging. But reality said there was this hill, and then there was this valley. And so it was a relative answer. Yes, that's the top of this hill. And so what I want to show you here is the idea of something called a relative maximum. So put yourself a colored dot on that top of that hill, so to speak. And that top, where that blue dot is called a relative maximum of this little curve. It's a high point of a curve for that specific part, that top of the hump of the hill. Okay? And then change colors and put a dot down here at the bottom of that valley. And that's called a relative minimum, meaning it's the bottom part of a certain section of the graph. Okay, so we have a relative maximum, a relative minimum. So let's kind of create some definitions here. A maximum would be a high point in a specific portion of the graph. And then in contrast, a relative minimum would be a low point in a specific portion of a graph. And a relative max and a relative min is a turning point. And later on, when we get to pre-calculus and calculus, we'll talk about the idea of a relative max and a relative min is when the slope of the whatever that's going across this roller coaster, so to speak, is horizontal. Because you could actually draw a line, and I'll draw it in green right here. And if you want to pretend you're like a roller coaster car, when you're going up a roller coaster, isn't there a part where you're sitting flat at the very top of the peak? Okay, and that spot where you're sitting flat is the relative maximum. And then you go down the roller coaster and you come down to the bottom, right? And then before you go up, there's a point when you're actually sitting straight up and down. And that point, once again, is the relative minimum. And then you go way back up and, it catches you and it takes you back up and things like that. So that spot up there and that spot up there are where the roller coaster, quote, quote, would be in a horizontal manner. It's called a tangent, called slope. All those different little ideas you don't need to worry too much about. So I'm going to erase my green lines and we'll make those go away. Now, 3 other important points. This one right there in the middle and that one right there. And those 3 green points are considered x-intercepts. And it's where the line, the polynomial, crosses the x-axis. Another fancy name for that is a zero. And so you can just put a little arrow here, and you can also say those are zeros. So if we're going to write a definition for what a zero is, I would say it is a point or points where the graph crosses the x-axis. Okay, so there's a couple terms that we're going to use today as we're working to our stuff. Relative max, relative min, and zeros. So far so good? Don't worry so much about the technical definition, so long as you can put it in your own words and be clear and explain it, that's perfectly fine. All right, let's move on. Now, we're going to take our graphing calculator and we're going to graph this equation. So, take out your calculator and we're going to graph x plus 1 times x minus 1 times x plus 3. I'm writing on the board just because I need to get a look at it. So switch to your calculator, and let's go to y equals, and whatever happens to be in there, I'm going to clear it out. And let's go x plus 1 times x minus 1 times x plus 3. And once you have that done, hit the graph button. All right. Everyone have something that looks like that. Does yours look like mine, or is yours a little bit different in shape? What do you notice about my graph? Is it a little bit big? Okay, so that's because I manipulated it last hour with my algebra class. So I'm going to go back to my standard, and that was Zoom 6, for those of you who remember. Does that look more like yours? Okay, so if you don't have the right function, you might want to hit Zoom 6, and that'll get it to the standard 10 by 10 graph. So here's our first question. The question says, find the zeros of this function. So a zero is where it crosses the x-axis. So let me show you how to find this. I'm going to go slow. Hit second, trace. And what's above second trace? What words? Calc, right? Now, do you see the second one down that says 0? Go down to 0 and hit enter. And what's the question it's asking us at the bottom? What does it want us to find? The left bound. So what we want to do is we want to go over far enough so we're left of our first point. So when I say our first point, I mean this spot right there. So we want to be left of that first point. So we want to pick something in this range over here. Okay? So take that in mind, and once you're left of that point, hit enter. Now what's it asking us for? A right bound. Would you say I'm now right of that 0? So hit enter again. And now we hit enter a third time, and it jumps right to the 0. So our first 0 is x equals -3. So I'm going to write that down. Now I'm going to go back to my graph, and I'm going to do this again. So let's review. Second calc. Now if you don't have a calculator, now I want you to borrow one from someone else, and you do it this time. So second calc, go down to 0. Now we want to arrow to the right to get close to the second 0. There I am. Enter. Arrow a little bit more to the right till you're past it. Enter again. And enter a third time. So our second 0 looks to be x equals -1. So now we have 2 of them. So now let's find our third 0. Second calc, down to 0, enter. Get somewhere close. Put in your left bound, put in your right bound, and hit enter. And our third 0 looks to be x equals 1. Now, was everyone successful in those steps? Karen?
Where did you put the second one? Like on the graph.
This one right here.
Or just did it.
I did second calc, and just watch. 0. I went slightly to the left of that, right about there,
Of what though?
of this spot right here,
Okay, how do we know that? Oh, so we're doing it where it crosses.
where it crosses the x-axis. That make sense? Do I need to go further? Are you okay?
That makes sense.
Okay. All right, so I'm going to go back to my graph, and I have 3 points. So I'm going to put my 3 points on my graph at -3, at -1, and at 1. Now, all of these graphs start low and end high, but that's as far as I want you to draw it at this point. If you draw anything in between, don't draw it. Do you remember a parabola? The beautiful thing about parabolas, they were always symmetrical. Gone are the days of symmetry. Okay? Cubic functions are not necessarily symmetrical. So you can't just say halfway in between 1 and -1 is where the minimum lies, and halfway between -1 and 3 is where the maximum lies. We actually have to figure them out. And so what we're going to show you how to do is how to figure them out. So go back to your calculator. If you're trading calculators, pass it back and forth each of these times. Sebastian, who are you trading with?
Mine just died.
Okay, then why don't you pass back and forth with Kylie or with Jessica? All right, go back to second calc. And this time I want you to go to maximum. Go to the maximum function and hit enter. And now I am keying in on this spot right about there. Would you agree that's about the maximum where my cursor is? So I'm going to go a little bit to the left of that. Hit enter. Then I'm going to go to the right of the hump and hit enter. And then hit enter a third time, and my calculator is now going to accurately calculate to 5 decimal places the maximum. Now, look at the x value. What is the x value? Let's write that down. Negative what? 2.15, and do I round up or no? Yes. 2.155. And my y value? 3.079. Whenever we are doing points in here, Peter, 3 decimals of accuracy. So, I have that written down. Let's plot that now. Negative 2.1 and positive 3.0. So negative 2.1, positive 3.0. So somewhere about there. And I know I've zoomed in there, and I'm just trying to show you it's not exactly at negative 2. Because if it was at negative 2, it would be symmetrical. But it's not. And it's not just at 3, it's at 3.1 or whatever. So, try to sketch this now. Connecting from the 0. And then come back down. Because that should be the highest point between those 2 points on your graph. And what do we call that point again? A relative what? Relative high point is a relative maximum. All right, now we're going to find the relative minimum. So go back to your calculator, switch teams, second calc. Now what function am I going to choose, max or min? Min. Hit enter. Go left bound, go right bound. Let's write down what we have. 0.155, 0.155, and negative 3.079. What's interesting about the max and the min? Look at the values. Are they somewhat similar? So it's a little bit reflexive on the x-axis, but not necessarily in between our two values. So I'm going to go back to there, 0.155, so just off the y-axis and just below the value of 3. So go ahead and sketch that. This is where it really helps to zoom in because it helps your sketch. Now, perspective-wise, what do you notice about my upper line up here? Does it look like I maybe drew it at the wrong angle? So I'm going to erase that. And I'm going to try to draw that more along the right angle. And I even feel like my bottom line was a little bit too wide. Does that look more like it's flowing now? So when we're trying to sketch a parabola, it was symmetrical. But when we're sketching a cubic function, it's going to have a different flow to it. How do you feel there? You okay? So what did we just talk about? Zeros, relative max, relative min, using our calculator to do so. By the way, if you have not put arrows on your graph, please do so. And go from there. Now, a little trivia question. Which of these three functions do you think leads to the x equals negative 3? It's the x plus 3 function. Because if you solve x plus 3 equals 0, Rebecca, you get negative 3. And then which one leads to the x equals negative 1? The x plus 1. And then the x minus 1 leads to that. But our answers are there. Those are our zeros, and those are our relative max. I'm just going to write down our relative max. So our relative max was negative 2.155, comma, 3.079. And our relative min was 0.155, comma, negative 3.079. Okay. All right, let's go down to our next one. Similar problem. What form do we call this one? What is this called? Used to be an oil company. Starts with an S. Ends with andered. Standard, yes, all right. Standard form. So let's take this equation. Let's put this equation into our problem. X cubed minus x squared minus 9x plus 9. So go back to your y equals, clear out whatever it is you have, and put in x cubed minus x squared minus 9x plus 9. Make sure I have that right. Minus 9, okay. Once you have that in, hit the graph button. Let's take a look. Starts low, ends high, right? What do you notice has become a problem here in what you're looking at? Can't see the whole thing. Okay, so what are we going to do? We've got to change our view. How do we change our view? What button? Window. Go to your window and go down to Y maximum. What do you want to change the 10 to? How high do you think you need to go? 15. Okay, I'm going to put in a 15. I'm going to hit graph again. Let's see how we did, Mr. Donasso. But you were close, right? So what do you want to change it to? Did you say 18? All right, changing it to 18 per Mr. Donasso. Let's see how we did. All right, we're on the screen. So we need to be on the screen, that way we can tell relative max, relative min. True? All right. Now, what would you say we need to find this point right here? That's a 0, right? We need to find this point right here. That's a 0. And we need to find this point right here. That's a 0. We also need to find a relative max up here. And we need to find a relative min down here. So we're going to do a little divide and conquer. All right. U5, the left-hand 0. Trevor, your row, the relative max. Alejandro, your row, the next 0, this one in the middle. Peter, your row, the relative min. And Krista and Mas, your row, the last 0. Okay? Do your function, find your value. Raise your hand when you have each of those values. We need 3 zeros. We need a max. And we need a min. Who's got some numbers for me? Kylie, which are you?
The relative max.
Relative max, go.
Negative 1.439.
Comma.
16.901.
Okay. What do you got? Okay, the middle one. All right.
No, 1.
1.
Oh, the middle one is 1. Sorry, I thought you said 0. Who else is something? Michaela, do you have the first 0? The left one, yes. It's what? Okay, that's fine. Krista, what do you have? 3? All right, who's got the relative min? Jessica?
2.097.
2.097, comma.
Negative 5.049.
And I need the first point. Luke? 3. Negative 3? Negative 3. Okay. That should be enough to plot. And by the way, I have a secret point that we're going to fill in at the end. I'll tell you that. You just have to wait in suspense. I know it's just killing you. All right, let's plot in our points. Negative 3, positive 1, positive 3, relative max, negative 1.4, 16. Well, if that's 8, then that's 16. So there she is, way up there. And then 2 and negative 5. All right, now for the secret point. The y-intercept is the point 0, comma, c. Do you remember that from the quadratic formula? ax squared plus bx plus c. Well, what's the final number? What's the constant in our problem? It's 9. So go up to 9, and that's your y-intercept. It's always good to know where it crosses the y-axis and where it crosses the x-axis. So now we should have enough points to sketch it. Now we have enough points. So I would start by sketching it. It's probably better to draw your middle curves first and your outside and inside ones last, because otherwise you're going to be off at the wrong angles. So how do these two compare to each other? How would you describe these two graphs to each other? Fairly different, aren't they? It feels like the second one is stretched vertically, and the other one was this nice little zoom, zoom, and boom, we're done. All right, so I'm going to label in red. Actually, don't have red. Let's see, what can we use? We'll use purple. There's my max on each one. And I'm going to put in red my y-intercept of each one. And then I'm going to go in black my relative min of each one. So there we go. There's our important points. And then obviously we also have the zeros. Questions? Remember, when you're drawing this graph, it should flow. It shouldn't have like cut-ins and cut-outs and, you know, swerves and things like that. Like sometimes.
So it has 3 answers: the relative mass, relative y-intercept.
Well, the question says, using a graphic sketch a copy of the graph. Okay, we found the relative max, we found the relative min, we found the zeros. The y-intercept, Stephen, is just an extra piece of information as you're drawing it to know, hey, where does it cross the y-axis? To kind of know what angle you should make as you're going down. That's all. It's almost a trivial question, what's the y-intercept? It's just more framework. All right, let's move down a little bit. And now let's kind of ease off on the difficulty level. I'm going to give you the zeros. So the first zero, it says, is x equals 2. The second zero is x equals -3. And the third zero is x equals 0. Well, x equals 2 leads us to a factor of x minus 2. And x equals -3 leads us to a factor of x plus 3. And x equals 0 leads us to a factor of x. With me so far? Do you see how I just reversed those? Now we're going to write a polynomial function. F of x equals x times x minus 2 times x plus 3. Does this have that same up, down, and back up thing? So let's do some multiplying. This goes back to Friday. Bring down the x, and I'm going to multiply the other ones. X squared plus 3x minus 2x minus 6. So that's x squared plus x minus 6. So it looks like my function is x cubed plus x squared minus 6x. Now let's do some review for our quiz, which is coming up on Wednesday. What is the quadratic term of this function? Raise your hand if you know. What is the quadratic term? Only a couple of us know. Alejandra? I just heard you say, x. There is no x term. That's x cubed, that's x squared, that's x. Sebastian? What's the quadratic term? What am I asking for? I'm asking for the term that has what exponent? A 2. So which term has a 2? Yeah, x squared, right? That's the quadratic term. What's the linear term? -6x. And what do we call this term? This x cubed?
Cubic.
Yeah, x cubed, cubic. All right, what type of polynomial is this? A trinomial. Okay, so here we go. Now we're going to do our sketch. So let's go back to our graph. I'm going to put a dot at 2, a dot at 0, a dot at -3. I guess I need to find some relative maxes and some relative mins. So let's go down to our equation, x cubed plus x squared minus 6x. I'm going to put that in, x cubed minus x squared. How convenient, we have it almost identically already. Minus 6x. I want to make sure that's the right one. X cubed plus x squared minus 6x. Okay, there we have it. I'm going to go back to my window, Mr. Donasso, and I'm going to change my window back to a standard view, just so I can be consistent in what I'm looking at. And it fits on my standard window. All right, gentlemen, I need the relative max. Ladies, I need the relative min. Go. Gentlemen, relative max. Ladies, relative min. We need those values with which to graph. I will do the relative max. Just as an example, we go down to max. Get the max for the minimum. Name that store. Negative 1.78, 8.20. All right, do you agree? Negative 1.7, guys, at 8.2? Ladies, what's my min? What comma what? Okay, comma. Say it again, sorry.
Negative 4.061.
Okay. There we go. All right, so Sketcher. So when you go home today and your dad says, so how was math today? You can say it was sketchy. I only got so much to work with. But your graph should have curves at the top, and it should be somewhat of a flow. Even it would be a steep roller coaster. A steep roller coaster to ride. I don't think I necessarily want to do that. Maybe on one of those little motorcycle video games, you know. I could do it there, but I don't even know if I want to ride this one on that one. Okay, so we've talked about zeros, standard form, relative max, relative min, y-intercept, using our calculator, graphing, sketching. It's a little sketchy though. Going from an equation to zeros, going from zeros to an equation. So I think we've got all the different possibilities there. All right, so short assignment. All of 9 problems, I think it is. And to make life a little bit easier on you, I cut and paste into your drawboard file right there. Okay? So why don't you go ahead and go to it? And you guys are going to be